Okay, sorry about that. Some paper 2 revision. Okay, a bit of a list for you. You can go away and look at some of these if you're struggling, right? Number 1, conversions. Okay, so the ones you need to learn off by heart. 1 litre is 1.75 pints. It's just something to know, you guys, unfortunately. 1 kilogram is 2.2 pounds. And 1 mile is 1.6 kilometers. If you're changing from these to these, so liters to pints, kilograms to pounds, miles to kilometers, you're going to times by the exchange rate or the conversion rate. If you're going the other way, you're going to divide by those numbers. So for example, if I was changing kilometers to the miles, I would divide by 1.6. Number 2, an awareness of probability, just an awareness. Okay, so for example, if I flip a coin, the probability of heads on the coin is 1 out of 2. If I roll a dice, the probability of landing on the number 3, for example, is 1 out of 6. There is only 1 3 on the dice. Okay. If I told you that the probability of landing on a blue on a spinner was, so the probability of blue was something like 0.37, then the probability of not landing on blue, okay, is everything else. You can almost think of these as percent. So if that's 37%, then there's a 63% chance of not landing on blue, or in this case, 0.63. Okay, the next topic, topic number 3, let's have a look at solving equations. All right, something like 3x plus 11 equals, I don't know, but I can make a number up here because I've got a calculator, guys. So I've got the calculator to do all this for me. So I could, if I was doing magic bridge, I'd go, okay, move the plus 11 over there and take away 11 from that side to leave me with 3x equals 17. So x equals 17 divided by 3. But because you've got a calculator, put it into your calculator and actually write the answer, maybe round the answer to 1 or 2 decimal points. The fourth topic might be something like function machines. Okay, if I put this is my function machine, so I got an input, then I'm going to add 11. Well, all this stuff is on MathsWatch, so I would encourage you, if you want more practice of these things, get on MathsWatch and do them there, okay? And an output. Okay, so if I put the number 4 in, I would add 11 to it to get 15, and then I would times that by 4 and get 60, so 60 would be my output. But if I put the letter N in, okay, I've just got to show what I would do to the N. So the first thing I would do to the N is add 11 onto it. I then would times by 4. However, you don't want to write it like that because otherwise that looks like you just want to times the 11 by 4 if we were following BIDMAS. So to show that we need to add the 11 first, you can put that in brackets to go, okay, take the N and add 11 in brackets. Once we've worked that out, times it by 4, and that would be your output there. And there's a couple of those on MathsWatch for you. Next topic, just an awareness of things like this. Topic 5, multiples, square numbers might be useful. Okay, things like that. So if I said, what are the multiples of 1.8? You've got a calculator. Just keep adding 1.8. The multiples of 1.8 would be 3.6, 5.4, and just keep adding 1.8, and you'd get all the multiples of 1.8. Square numbers, what are they? Well, 1 is a square number because it's 1 times 1. 4 is a square number because it's 2 times 2. 9 is a square number because it's 3 times 3. And then moving forward, we'd have 4 times 4, which is 16, 5 times 5, 6 times 6, 7 times 7, 8 times 8. And it might be worth knowing these all the way up to 100, which is 10 times 10. Okay, so there's your square numbers and multiples. Topic 6, bear with. And just calculator work. An ability to use the calculator. So if I said something like the cube root of 142.8, right, times 9.2 divided by 3.62, I don't know, something like that. Would you know how to put it in the calculator? Do you know that to square a number on the calculator, you've got that button, or to cube a number, you've got that button, or to square root, you've got that button, or to cube root, you've got that button? And also, can you use the fraction button to write if there is a fraction to put in, which is that button there? So maybe practice, put that one into your calculator that I've done there. I'm not going to work out the answer here, but you also need to be able to round your answers. Could be to decimal places, something like 1 decimal place. Could be to like the nearest 10 or 100, or it could be rounded to significant figures. Are you happy with rounding to decimal places, nearest 10, nearest 100, sig figs? But it's what you're doing is you're rounding your answers to these sums here that will go into the calculator. Topic 7. A little bit of time work, guys. All right. I'm not going to say too much more on that one. So if I don't know, for example, if on Monday I worked for 12 hours, right, and then I say on Tuesday I worked the same amount of hours, on Wednesday I worked half the amount of hours, on Thursday I might double the amount of hours, or whatever, something like that. How many hours did I work that week? Okay, so again, I don't need to say too much about that. You guys are more than comfortable working, halving numbers and things like that. Okay, we've done translation in paper 1, but there's also a translation in paper 2. It's a little bit easier, okay, guys? So it's just moving a shape, but this time they're not going to use what's called a vector. They're not going to give it in vector form. They're actually going to tell you, move it 3 squares to the right and 2 squares down, for example. So you'll take a corner and go, well, I need to move this 3 squares to the right and 2 squares down, so that would be there. And do the same with every corner then. And so it's just moved. So that's translation. Also be aware of reflection. Okay, so if I draw just really roughly, and again, this is not a high quality video, it's just to give you an idea. If I said I wanted you to reflect this in the line y equals 2, then you would need to draw the line y equals 2, and if every point that's above that line will then need to come below that line. So if that's 1 square above, it'll need to come 1 square below. If that's 1 above, it'll need to come 1 below. If that's 3 squares above, it'll need to come 3 below. And you'd end up with something, I don't know. I know that's not the best, but below. But you're just reflecting it below that line. But it's an ability to draw lines like y equals 2 or y equals 3 or y equals 4, which are horizontal lines. The line x equals 1, that would be that way, right? If that were 1, or x equals 2, or x equals 3, etc. Okay, so y lines horizontal, x lines vertical. Okay, topic 10. Right. Got to be able to do something like this, I guess. You need to know how to calculate a fraction of an amount. Right, so need to be able to divide by the bottom and times by the top. So 40, do that bit first. 42 divided by 7 is 6. 6 times 2 is 12. Also a little bit of ratio in here, okay? Maybe let's take the answer, 12, and share it in the ratio 1 to 3. So we would do add, which is 4, divide the 12 by whatever they added up to, by 4 in this case, which is 3, and multiply. So take the answer 3 and multiply it by 1, which was the first number in the ratio, to get 3, and then take it and multiply it by 3, which was the second number in the ratio. Okay, so a little bit of knowledge. If you wanted to revise this, we're looking for fractions of amounts, and sharing in ratio. That would be on the revision list. Topic 11. Right. Again, topic 11 involves drawing a line. So if I said draw the line x equals 3, we'd have to find where x were 3 and draw the line x equals 3, right? If there's another line already on there, like a diagonal line, be prepared. This here is called where they intersect. So where that line intersects the line x equals 3, okay? And you might have to give the coordinates of that line then. So say that, I don't know, let's make it up 7. Then the coordinates of that point would be 3, 7. That is where the lines intersect. Okay, so points of intersection is kind of your revision topic there. I've forgotten what number we're on. I don't know, something like 11 maybe. Okay, it is. So percentages of amounts, done fractions. I don't think it's the nicest question, this one. I can't quite remember what it is, but so do this. Something like, what percent of 84 is 8.4? Right? Well, the decimal point has moved back a place. We've divided the 84 by 10, so that is 10%. Okay, what percent of 22 is 4.4? Right. Well, 10% of 22 would be 2.2. That is double 2.2, so this must be 20%. It's double 10%. Okay. Also, with things like percentage of amounts, if we do flip it and we actually have to do one, if I said, how would you find, no, let's give a different number. Let's go for 26.4% of 87, yeah, whatever, okay? Then, two ways to do it. I think the one that most of you use is you take the number, you divide it by 100 to get 1%, and then you times it by whatever percent you want. The other option is to change 26.4 into a decimal, but that's hard. It would be 0.264 and do it like that. Okay, either of those is good. Okay, either of those is good. Topic 12, areas of circles. Right, areas, you've done circumference in paper 1. Area is pi times the radius squared. Okay, so if I had something, you've got calculators by the way, right? If I told you that that were 12 centimeters, right, then the area of this circle would be pi, which is 3.14 times what I've given you there. The 12 is the diameter. The radius will be 6, but I need to square it in my calculator like that, and whatever answer that gives me, that's in centimeters squared. Okay, so just an awareness of how to work at areas of circles would be good. Right, we're now on to a topic that we haven't talked a lot about. There's some angle things that we haven't done much of that we need to, okay? Right, bearings. We will be doing this in the next couple of weeks. So again, it's one of those that we can't over-revise for this, right? But if I said, what is the bearing of B from A? What is the bearing of B from A? So measuring from A, so I'll write that there. What is the bearing of B from A? You need to connect the points up like I've done there with a straight line, and you're measuring the angle from A, and it's always from north, so it's that angle there. How far do I turn from north until I'm on that line which is pointing to B? You're going to need a protractor, and you'd measure that bearing, but it looks like it's a little bit bigger than 90, so I'd expect that to be in the 100 to 110 range. Let's call it 105 degrees. Okay, so a little bit of an awareness. So that should be enough to get you through this, but we will do more on that as time goes on. Okay, drawing quadratic. I've completely lost count of my numbering system. Drawing quadratic graphs. All right, so if I asked you to draw y equals x squared plus 7x plus 11, right? And I say, okay, we got a little table, right, with X and Y, and they tell you some of them, right? So they might go, when X is -2, this is blah, 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 and they'll tell you that one. And when X is -1, but they won't tell you that one. And when X is 0, they'll tell you that one. And X is 1, they might tell you that one. And then when X is 2, so there's 2 blanks here that we need to fill in, okay? So let's start with the easier one, which is the positive number, which is 2. So every time I see X, I'm going to put in 2. So instead of X squared, I'm going to write 2. And you know I like to use brackets when I'm substituting in, like when I do trial and improvement. Plus 7 times 2 plus 11. And whatever answer I get there on my calculator, I put it there. I then do the same thing, but with -1. That's the bell going in school. I'll keep working. And we put our answer there. So we're just substituting those two numbers into there instead of X and putting them in the calculator and working them out. Okay, I'm going to go with 15. It might not be, but something like 15. The next topic is volume and area. Now, you've got these given to you in the front of the paper. There's a formula list at the front, and the two formulas that are given at the front are the, so you don't need to learn these, okay? Area of a trapezium, and that is given as half, in brackets, A plus B times H, right? Now, they even draw a little picture of the trapezium at the front, and they label it for you. So A is the top, B is the bottom, and they show you in that picture that H is the height, okay? They also give you this formula that the volume of a prism is equal to the area, now they call it the cross section, but basically the front, times the depth. So what area is the front of the shape, and then times it by the depth. Merging those two things together, we could get a question like this, okay, where I'm trying to draw a three-dimensional trapezium, okay? If I put, for example, 3 here, 7 here, I'm keeping the numbers so that I don't need a calculator, but you will have a 6 there and a 2 there. Then start with the area. The area of the front would be, this trapezium here, looking up here, would be half, in brackets, the top plus the bottom times the height. Okay, now do this in any order you like. Brackets first, probably 3 plus 7, right? Top plus bottom is 10. Half it then, half of 10 is 5. 5 times 6 is 30. That's the area. Now the volume is the area times the depth. How far back the shape goes, okay? So this would be 60. Now, units wise, centimeters squared for area, centimeters cubed for volume. Next slide. And next up, we have got density. Again, not something I've mentioned too much, okay, if at all. So it's one of sort of newish type of thing, okay. Density, mass, volume, okay. Think of it like speed, distance, time, right? To work out the density, it would be equal to the mass divided by the volume, or to work out the mass, it would be the density times the volume, or to work out the volume, it would be the mass divided by. So you cover the one you want. So in the case, if we wanted mass, we'd be doing density times volume. Now, bearing in mind, in the last slide, we actually worked out the volume of a shape. Knowing that we know the volume of the shape, having just worked out the volume of the shape, if they told me the mass or the density, I could work out the other one. So I think on the last slide, we had a volume of 60, if I remember the answer right, to the example I gave. Well, if I now tell you, for example, that the density of that is 3 grams per centimeter squared, whatever, cubed, sorry, squared, then the mass of that shape in the last slide would be equal to the density 3 times the volume I've worked out 60, so it would be 180 grams, right? Fantastic. Next slide. Right, next up, a bit of probability again. Go back to what you did in paper 1. Very similar thing, spinners game, yeah? In paper 1, you were told that there was a spinner with 4 numbers on. A lot of you favoured a list over this, but it's super important you list winning scores as well as and losing scores, okay? A table is nice. So what we could have done is gone, right, if I got a 1 and a 1, my score in paper 1 was 2, 3, 4. Or 2 and a 1 is 3, 4, 5, 4, 5, 6, etc. And I am rushing, and 5, 6, 7. We were told then to win, you have to score 6 or more. So there are 3 winning scores out of 12 possible scores. And this is in an add-in game. Add the spinners together. Yeah, spinner 1 down here, spinner 2. You can do that the other way around. It doesn't have to be spinner 1 on the bottom and spinner 2 on the side. Or a list, but I will need a full list of every single score you can get. Very, very similar to paper 2, but in paper 2, just read the question. It might not be that you add your spinners. It might be that you times them or take them away or something like that. Okay, just have a little read of that one. 16. Again, I might be in the wrong place in terms of numbers, but is Pythagoras. So 15 is probability or probability spinners, and then Pythagoras. Square, square, add, square root. If you're finding the big side. So if I label my triangle ABC, in order to find the side AC, then we would square this number here, square this number here, so 9 squared, 10.4 squared. We would add our answers together and then square root whatever they add up to, okay? And then round your answer as they would like you to, okay? They might say in this one, round to 1 decimal place or 2 significant figures or whatever they want, okay? Keep an eye on that. Right, next slide. Next up is trial and improvement. Okay, so what we're going to be given here, it'll say there is a solution. I'm not going to write the full thing. There is a solution to something like this. All right, and that solution lies between, and you have to get as close to 30 as you can, you know, using numbers between 3 and 4, only to 1 decimal place though, okay? So you're going to say, right, I'm going to start by trying 3.5, which is in the middle. So I need to do 3.5, and look, it's not squared, it's cubed, okay? Plus 3 this time, times 3.5 equals, work it out. Tell me, if the answer's above 30 or below 30, is the answer that you get to that too big or too small? If it's too big, which I think it would be in this case, try 3.4. If that's too big, try 3.3. And keep going until you get one that is below 30. Keep too big, too big, too big, too big. All right, I've now found one that's too small. Then do your check. X equals whatever your check is, 3 point whatever. 2.5 it could be, if it was between 3.2 and 3.3. And you can check that and then give your final answer, which would be whatever it is, 3.1, 3.2, 3.3, or whatever. Okay, that's trial and improvement. Do make sure you have a go at that. Okay, next we're going to do expanding double brackets. Okay, all right, so I'm going to give it to you like this, right, in a strange sort of shapey sort of way. So if I said 3x minus 2 and 4x plus 7, I don't know, and I said what is the area of that in algebra form? Okay, what is the area in algebra? Or write, sometimes saying write an expression. Don't worry about words. Words will put you off. Write an expression for the area. In other words, you're not going to get a number, so put a bit of algebra. Put an algebraic expression, a bit of algebra down, okay? So the area is the length times the width. and we're going to do like a smiley face or foil or whatever your teacher would teach you. We're going to expand. 3 4s are 12, x times x is x squared. 3x times 7 is 21x. 4x times 2 is 8x, but we're not timesing 2, we're timesing minus 2, so it's minus 8x. 2 times 7 is 14, but positive 7 is times in a minus 2 again, just minus that. And then we could simplify that by combining those together. 21 take away 8 is 13x minus 14. And our last slide that we're going to do together, I totally lost count, but this, okay, it's doable. It's called the estimated mean. Not revised this term, probably not done until we did that, since we did averages. Can't remember, that was sort of in year 9 or when that was. But what you've got is a table, right, with groups in it. So let's say the table is groups of weight. So I'll put W for weight. So the first group is 10 up to 20. And then there's a frequency column. And let's pretend there's 4 people in that group. Then the next group is 20 up to 30, and let's go for 5 people in that group. And the next group is 30 up to 40, and there's 1 person in that. In other words, there are 10 people altogether, and 4 of them are in the first group, 5 in the second. Okay. To estimate the mean from a table, you have to do the midpoint of the group. This is my workings out now. Midpoint of the group, so 10 to 20, halfway between 10 and 20 is 15. And you multiply that by the frequency 4. So here I get 60. The midpoint of my next group, 20 to 30, is 25, and I multiply it by 5, and I get 125. And the midpoint of my last group is 35, and I multiply it by 1, which is 35. Okay, so midpoint, or that's what we call the midpoint, the middle of the group times the frequency. You then want to be adding these together. 5 and 5 is 10. You've got a calculator. 6, 7, 8, 9, 10, 11, 12. And then 2, so 220. Okay. And then finally, the mean is add them all up, which is what we've done there. We've added up our answers, but divide by how many there are. Big mistake, people divide by 3 because they've added up 3 numbers. It's divide by how many people there are. So we're dividing that by 10. I don't know why I've written 222 there when it's 220. Right, so 220 divided by 10, you've got a calculator, but the answer to that would be 22. So midpoint times frequency, midpoint times frequency, midpoint times frequency for every single group. Add them up and then divide that answer by how many people there are. And the final thing, okay, relies on knowing this, but I'm not going to say any more. It relies on knowing this. Okay, because I think it's a very, very tricky question. I don't want to confuse you too much. It relies on knowing that they add up to 180. Angles on a straight line add up to 180. And you also need to know that angles in a 4-sided shape, angles inside there, so this one, this one, this one, and this one, they would add up to 360. So you just need to be aware of that. Right, don't worry about too much about that last question, but be aware of it. And that completes this. Okay, so we're under half an hour, so it is very much a rush through. The extra revision I would be doing on top of this would be going on to MathsWatch, okay, and trying the paper 2 revision. Everything you do from now in this paper is calculator, so the paper 2 revision and this is calculator. So as I said, if you need to, watch the video again. Alternatively, onto MathsWatch now, onto the paper 2, and try and complete that for me. Let me know in Teams if there's any questions on MathsWatch you're really struggling with, and I'll make short videos for each of those. Hopefully that'll prepare you nicely for Monday. Bye.